Welcome back. In this video, I'm going to cover the three different types of factorial designs. The three different types are between subjects, within subjects, and mixed factorial designs. And my goal is for you to understand the definition of each type of factorial design, a little bit, or the basics of how each one is conducted or carried out, and also a little bit about the pros and cons of each type of factorial design. So let me just give a quick description of each type of factorial design. So in a between subjects factorial design, each cell has a separate group of people. So in a between subjects factorial design, the participants are randomly assigned to separate groups, and each group goes to one specific cell of the design. In a within subjects factorial design, a single group of participants goes through all of the cells one at a time. And they don't all go through the cells in the same order. In other words, if there's 4 cells, every participant doesn't go cell 1, then 2, then 3, then 4. Also, every participant doesn't go 2, 1, 3, 4, because you have to, just like in any type of within subjects design, you have to send different participants through different orders and counterbalance the experiment. So if you're doing a within subjects factorial design and you have 4 cells, in other words, 4 conditions, some people will be doing 2, 1, 3, 4. Other people will be doing 2, 4, 1, 3. Other people will be doing 4, then 1, then 3, then 2. So different people will be following different orders. In a mixed factorial design, each participant, in a mixed factorial design, the participants are randomly assigned to separate groups, and each group goes to one specific row or to one specific column, and then all of the participants go through all of the cells in their assigned row or through all of the cells in their assigned column. And I know this sounds confusing right now if you don't have kind of a concrete picture or example to look at, but I think you'll see what I mean once we go through a few examples and some visuals. So here's a between subjects factorial design. So pay attention to the ID numbers that I used. So notice how we have a total of 16 people, and 4 people went to classical music at 60 degrees, 4 people went to rock music at 60 degrees, 4 people went to classical at 90 degrees, and 4 people went to rock music at 90 degrees. But notice how each of the 4 cells is a different group of people. So in this imaginary experiment, the researcher took 16 people, randomly assigned them to 4 separate groups, and then each group went to one specific cell. So it's group 1, group 2, group 3, and group 4. It's 4 separate groups. This is a between subjects factorial design. Now let's look at a within subjects factorial design. And once again, pay attention to the ID numbers that I used here. So this experiment, this imaginary experiment, has only 4 people. Person 1, 2, 3, and 4. And this group of 4 people is experiencing all 4 conditions. So, for example, person 1 is going through all 4 situations. Person 2 is going through all 4 situations, and so on. So that means the researcher is gathering 4 numbers from each person. So, for example, person 1 has a score for cell 1, a score for cell 2, a score for cell 3, and another score for cell 4. It looks like for person 1, the 4 scores are 90, 80, 78, and 75. Those 4 numbers all came from person 1, the same person. So this is a within subjects factorial design in which each person, you have one group, and each person goes through all situations or all cells of the design. And like I said before, these participants aren't following the same order. So it could be that person 1 is doing classical at 60 degrees first, and then going to rock at 90, and then back to classical at 90, and finishing with rock at 60. And it could be that person 2 is doing rock at 60 at time 1, then moving over to classical at 90, up to classical at 60, and finishing with rock at 90. So they're not all following the same order because it's counterbalanced. Here we have a mixed factorial design. A mixed factorial design is a hybrid because it's part between subjects and part within subjects. It's half and half. That's why it's called a mixed factorial design. It's a mixture of between and within subjects. And once again, pay attention to my ID numbers. So notice how in this experiment there are 8 people, and they've been separated into 2 separate groups. They've been randomly assigned to 2 separate groups of 4. So group 1 is persons 1 to 4. Group 2 is persons 5 to 8. And the first group has been assigned to the 60-degree temperature, and the group 2 has been assigned to the 90-degree temperature. So in this experiment, we have a 60-degree group and a separate 90-degree group. And each participant is going through both types of music. So all 8 people are experiencing classical and rock, one at a time. And if you're in the 60-degree group, you're doing both types of music at 60 degrees. And if you're in the 90-degree group, you're doing both types of music at 90 degrees. So, for example, person 1 is being tested at classical, with classical music playing at 60 degrees, and also with rock music at 60 degrees at 2 separate points in time. Person 5 is being tested with classical at 90 and with rock at 90 at 2 separate time points. So what's happening in this mixed factorial design is that the participants are being randomly assigned to separate rows. So group 1 is going to row 1, group 2 is going to row 2, and each group is experiencing all cells in his or her, in their assigned row. So if you're in the 60 degree, if you're in row 1, 60 degrees, you go across all cells in row 1. If you're assigned to row 2, you go across all cells in row 2. So you're assigned to a specific row and you travel across your entire row, basically. Now, what if this had been a 3x2 factorial design and there had been a third type of music? What if it had been classical, rock, and jazz? Well then, if you're in the 60-degree group and you've been assigned to row 1, you would go through all types of music, classical, rock, and jazz, every time at 60 degrees. And if you're in the 90-degree group, you would go through all 3 types of music at 90 degrees. So once again, your participants would be assigned to one row and travel across all cells in that particular row. Now, you might be wondering, why can't we turn this around and have group 1 be column 1 and group 2 be column 2, and have group 1 travel down column 1 and have group 2 travel down column 2? So, well, I could have actually made this picture in that way. So I could have put temperature up here at the top, and I could have put type of music on the side. And if I had done that, then the 2 groups would have been column 1 and column 2, because 60 would be here and 90 would be here, and the 60-degree group would go down the 60-degree column, and the 90-degree group would go down the 90-degree column. So it's really it really just depends on what way you decide to visualize. It depends on which way you decide to look at the it basically just depends on how you decide to create this this diagram. It's really just arbitrary. So now let's talk a little bit about what happens in each type of design. So in a between subjects factorial design, you have random assignment to conditions, just like in the between subjects designs we were talking about a few weeks ago. And in a within subjects factorial design, you have counterbalancing, just like in the within subjects designs we were talking about a few weeks ago. And in a mixed factorial design, you have both random assignment to conditions and counterbalancing. So let me show you some pictures to help you see what I mean. So here we have a between subjects factorial design. We have two independent variables. We have type of music with its two levels of classical and rock. We have temperature with its two levels of 60 and 90, which creates four cells, four conditions. And we're going to take our 16 people and randomly assign them to four separate groups. And each cell has its own group of people. So that's random assignment in a between subjects factorial design. Within subjects, factorial design has counterbalancing. So imagine we have the same four cells, and now each person is going through all four of them one at a time. Well, we would still randomly assign our participants to four groups, but now each group would be a different order. So group one would be A, B, D, C, and they would go through the conditions in this order: A, then B, then D, then C, which is this order right here. The second group would be B, C, A, D, and they would do condition B, then C, then A, then D, and follow this order. And we would have two more groups. The third group would be C, D, B, A, and the last group would be D, A, C, B. They're just following a different order. So all 16 people are going through all four conditions. It just happens to be that they're not all following the same order. You have 1/4 of them following order 1, a fourth following order 2, a fourth of them following order 3, and a fourth of them following order 4. That's counterbalancing in a within subjects factorial design. Now, I said a mixed factorial design has both random assignment and counterbalancing, random assignment to conditions and counterbalancing, and this picture is meant to show you what I mean. So let's go back to that example that I was showing you earlier where the participants were randomly assigned to two groups, a 60 and a 90 group, two different temperatures, and each person was going through both types of music at his or her assigned temperature. Well, just like I said, half the participants would go to the 60-degree group, half of them would go to the 90-degree group. So looks like here we have 8 people at 60, and down here we have 8 people at 90. So the participants have been randomly assigned to two groups, and the two groups are 60 and 90 degrees. And after the participants have been randomly assigned to the two temperatures, the two types of music would be counterbalanced. So, sorry. So half of the 60-degree group would follow the AB order, which means classical first and rock second, and the other half of the 60 group would follow the reverse, rock and then classical. And the first half of the 90-degree group would follow the AB order, classical first, rock second, and the other half would follow the reverse, rock first, then classical. So we have, in this experiment, we have random assignment to the two different levels of temperature and counterbalancing of the two levels of type of music. And I mentioned that a mixed factorial design is halfway between subjects and halfway within subjects. So notice how in this experiment, each participant is going to 60 or 90 degrees. but not both. That means that temperature is between subjects because each person gets one or the other. Also notice how each person is going through both types of music. So type of music is within subjects. So basically, it's like we're combining a between subjects experiment on temperature with a within subjects experiment on music and putting them together into one experiment, and it becomes a mixed factorial design. Now I wanted to quickly talk about the advantages that a mixed factorial design has over the two other types of factorial designs. First of all, it requires fewer participants than a between subjects factorial design. Think back to that example of a between subjects factorial design that I showed you, and um, realize how it requires, well, take a moment to think about how it requires four separate groups of people. So you have to have separate groups of people recruited, which might not sound too bad. That's not too hard to recruit. But what if it wasn't just a 2 by 2 factorial design? What if it was a 4 by 4 factorial design with 16 cells? Well, then you would need 16 groups of people, which is quite a bit. So if the design gets bigger and more complex, it becomes difficult to do a between subjects factorial design because every cell has to have its own group of people. A mixed factorial design doesn't require as many participants as a between subjects factorial design. That's because you don't need a different group for every cell. For example, let's look back to this mixed factorial design. So temperature is between subjects, so we need one group for 60 and one group for 90. We need one group for each level of temperature, but we don't need a separate group for every cell. We don't need a separate group for every combination in the design, which helps bring down the cost and effort and time that it takes to do the experiment. So it's definitely practical to do it with mixed factorial design because you don't have to recruit as many people. Also, number two, in a mixed factorial design, each participant goes through fewer testing sessions than he or she would in a within subjects factorial design. So I mentioned before that in a 2 by 2 factorial design, if it's within subjects, each person goes through 4 testing sessions, one time per cell, which doesn't sound like too long of a sequence, but once again, what if it wasn't just a 2 by 2 factorial design? What if it was 4 by 4? Well, if you wanted to do a within subjects 4 by 4 design, you would have 16 cells, and each person would have to go through all of them and be tested 16 times, which is a pretty long sequence, which can be tiring and fatiguing for the participant. And you might have some people dropping out before they reach the 16th session. So a mixed factorial design is nice because it doesn't require as many testing sessions because each person doesn't have to go through all cells. Each person just has to go across, each person has to go across all of the cells in his or her assigned row, but not every single cell in the entire design. So like I said, in a mixed factorial design, you don't need as many participants as you would in a between subjects factorial design, and you also don't have to test each person as many times as you would in a within subjects factorial design. So this is an advantage of a mixed factorial design compared to the other two types. And finally, a mixed factorial design allows you to run a within subjects design with a participant variable as your second independent variable. So now imagine that I Imagine that I want to redo that experiment that I've been showing you in this video, but instead of instead of having my independent variables be temperature and type of music, I decide for them to be gender and type of music. In other words, I decide to have males and females and rock and classical. Well, I would have four cells, and um, gender would be between subjects because each person would be male or female. I would have a male group and a female group. And then what I could do is test all of my male participants in both classical and rock, and also test all of my female participants in both classical and rock. And I would have a mixed factorial design with a participant variable as my second independent variable. So that's one. Um, this is one thing that a mixed factorial design allows you to do. And yeah, so those are the three pros of a mixed factorial design that I wanted to talk about, the three main advantages. And that wraps things up for this video. Just let me know if you have any questions.